Yes, take down next problem. Okay, take down next problem. In a typical 3-hour storm, producing 60 mm runoff from a basin and its flow ordinates are follows. This one, time is given and flow ordinate are given. Okay, these two columns are given data. Okay, continue. Estimate the peak flow and the time of its occurrence. Peak flow and time of its occurrence. That means peak flow ಯಾವಾಗ ಬರುತ್ತೆ ಅಂತ. Its time of its occurrence in a flood created by 6-hour storm which produces 30 mm of runoff during first 3 hours and 45 mm runoff during second 3 hours. Now listen, in this problem compared to the previous two problems, this is a kind of different one. Okay, here time is given. Okay, this is given data. Okay, this is given and also this is given. Flow is given. In this problem we need to calculate peak flow. Okay, here we need to calculate peak flow and its time. Peak flow and its time. Okay, and also here they are clearly mentioned. Okay, the totally 6-hour storm is there, but they are clearly mentioning 30 mm of the runoff during first 3 hours. Okay, 30 mm of runoff, 30 mm, nothing but 3 centimeter of runoff during first 3 hours. Okay, during first 3 hours. There are actually in the problem totally 6-hour storm is there. Okay, for the first 3 hours this is the runoff depth. Okay, similarly they are mentioning 45 mm, nothing but 4.5 centimeter of runoff during second 3 hours. In the problem only they mentioned. Okay, second 3 hours. From the first 3 hours, total there will be 6-hour storm. In the first 3 hours, the runoff depth is 3 centimeter. In the second 3 hours, the runoff depth is 4.5 centimeter. Okay. Finally, we want peak flow and its time of occurrence. Okay. Simple. Listen carefully. Time is given. Flow ordinates are given. Convert this flow ordinate into unit hydrograph. This is the first step. After converting the unit hydrograph, listen carefully. Ordinate of flood hydrograph, this is unit hydrograph. Now I am converting the flood hydrograph into unit hydrograph into flood hydrograph, because the runoff depth is different for the different hour. Okay, for the first 3 hours the runoff depth is different, for the second 3 hours runoff depth is different. So first convert the given flow into unit hydrograph. After converting the unit hydrograph, again convert this unit hydrograph into flood hydrograph corresponding to 3 centimeter runoff depth, and again for the next 3 hours corresponding to next 4.5 centimeter. Okay, you will be understanding. Okay, don't worry. Flow hydrograph is given, convert this into unit hydrograph. This step you know very well, just previous problem only we did the same kind of problem. Convert this 0 we are converting to unit hydrograph, so divided by runoff depth 60. Okay, this is first one. This is divided for consecutive 3 hour 3 hour. Okay, this is for different. Okay, this is actually runoff depth, so 60 mm, so nothing but 6 centimeter. Okay, 0 divided by 6, 1220 divided by 6, 4060 divided by 6. Okay, just convert the values. I'll write directly. Okay, I'll write directly. 4060 divided by 6, you will get this one. First value 0, second value 203.33, and third value 676.67, and next value 1125, next 945, then 750, next 562.5, 383.33, 225, 83.33, and 0. Okay, now I converted the given flood hydrograph of runoff depth 6 centimeter into unit hydrograph. Unit hydrograph nothing but the depth is 1 centimeter. Okay, now ordinate of the flood hydrograph, listen carefully, ordinate of the flood hydrograph generated by the first 3 hour. First 3 hour ge runoff depth is given 3 centimeter. So nothing but this is the flood hydrograph. This column is the ordinate of the flood hydrograph of rainfall excess 3 centimeter. Similarly, this is the flood hydrograph ordinates, okay, generated by 4.5 centimeter. Andre next 3 hour runoff depth is 4.5 centimeter. Now just convert. Now I am converting the unit hydrograph into flood hydrograph. Okay, 0 into 3, you will get 0. Now 203.33 into 3, next 676.67 into 3, you will get some value. 1125 into 3, you will get some value. Okay, just 0. Multiplied by 3, yes, 0, 609.9, 2030.01, 3375, 2835, okay, 2835, 2250, 1687.5, 1149.99, 675, 249.99, 0. Converted unit hydrograph into flood hydrograph of rainfall excess 3 centimeter. This is unit hydrograph, 1 centimeter depth. Now I converted unit hydrograph into flood hydrograph for the first 3 hours. For the first 3 hours, the runoff depth is 3 centimeter. Okay. Just multiply the unit hydrograph into corresponding rainfall excess 3. This multiplied by 3, this multiplied by 3. Very similar to previous problem. Very similar to previous problem. You will get the ordinates of the flood hydrograph for the first 3 hours. Total rainfall is 6 hours. First 3 hours we got ordinates. Now these are the ordinates for the first 3 hours. They are clearly mentioned for the second 3 hours. For the second 3 hours, the runoff depth is 4.5 centimeter. So we need to lag the ordinate by 3 hours. Just I'm lagging the ordinates because now this 4.5 centimeter runoff depth is for the second 3 hours. Okay, so first 3 hours 0 to 3. So this is lagged by 3 hours. Okay, now we have to write the ordinates from this point because rainfall depth for the second 3 hours. First 3 hours is completed. Now I am writing the ordinates of the flood hydrograph generated by second 3 hours. So corresponding depth is 4.5 centimeter. So we must lag this ordinates by 3 hours. Okay. Now everything is same. Okay. Unit hydrograph is how much? 0 into 4.5. 0 into 4.5 you will get 0. Now 203.33 into 4.5. Next 676.67 into 4.5. Next 1125 into 4.5. Next 945 into 4.5. Similarly for the rest of the ordinates 750 into 4.5. Calculate by yourself. Value is lagged by 3 hours. Next value is 0. Next 914.85 3045 5062 4252 next 3375 2531 1724.98 1012.5 next 374.985 next is 0. Okay. Now these are the ordinate for the first 3 hours corresponding to the rainfall depth 3 centimeter. These are the ordinate for the second 3 hours corresponding to the rainfall depth 4.5 centimeter. But this ordinate is lagged by 3 hours because this is the second hour. Second 3 hours. These are the ordinate for the first 3 hours. Total rainfall is 6 hours. Total rainfall is 6 hours. First 3 hours ordinate is finished corresponding to this rainfall depth 6 hours. First 3 finish. Next 3 hours. Okay. 6 hours. First 3 hours is finished. Next 3 hours. So lagged by 3 hours. Okay, correspondingly multiplied by 4.5 centimeter rainfall excess to the unit hydrograph, you will get these ordinates. Now, final step, ordinate of the flood hydrograph generated by 6 hour storm. Correct? 3 hour storm, 3 hour storm, 6 hour storm. Just add 0, 609.9 plus 0, you will get 609.9 only. Now, I am writing 2 steps, okay, for the understanding purpose. 2030 plus 914.85, you will get some answer. Now, 3375 you can write 0. Okay, here 609.9 plus 0. 609.9. Now 3375 plus 3045. Next 2835 plus 5062. You will get some answer. Now 2250 plus 4252. The procedure. Write yourself. Okay. Now I am writing directly the values. 609.9, 5075. Now 6420, 7897.5, 6502.5. Next 5062.5, 3681, 3681.24. Next 2399.98, 1262.49, 374.985, 0. These are the ordinates of the flood hydrograph generated by 6 hour storm. Finish. Okay. Actually, they are given time and flow. Convert that into unit hydrograph. Why we are converting means because here the rainfall depth for consecutive years are given. So just convert flood hydrograph into unit hydrograph, correspondingly multiplied by the rainfall excess depth for the first 3 hour, for the second 3 hour. Now this is for 3 hour, this is for second 3 hour. Just add 3 hour plus 3 hour, 6 hour flood hydrograph you will get. So this is the procedure. Okay. In the last problem itself, actually they were asked to find peak flow and its time of occurrence. Okay. This is the peak flow 7897 and its time of occurrence. Okay, this is the peak flow and time. Okay, 7897 meter cube by second. So this is the peak flow, correct? 6420. Actually, this is a graph like this. So 6420, 7897, 65. So this is the peak point and its time of occurrence is time. So this is the end of the problem. Actually, they were asked to find peak flow. Okay. Yes. Take down next problem. Problem number 4. The following are the ordinate of unit hydrograph. Following are the ordinate of unit hydrograph. Derive and plot the 6-hour flood hydrograph. 6-hour flood hydrograph. Due to an excess rainfall 35 mm. Due to an excess rainfall 35 mm. Also calculate the volume of discharge. Also calculate the volume of discharge. Okay. Again, simple problem, one step extra. That is the calculation of volume. Okay, in this problem, rainfall excess is how much? 35 mm. Okay, in this problem, rainfall excess. In this problem, rainfall excess 35 mm, nothing but 3.5 centimeter. Okay, time is given data. 6-hour unit hydrograph. This is unit hydrograph, given data, and we need to convert unit hydrograph into flood hydrograph. Okay, just similar kind of problem we did in last 3 problems. Again the same thing. Convert the unit hydrograph into flood hydrograph. Very simple. 0 multiplied by rainfall excess. Flood, this is flood hydrograph. Okay, this is the unit hydrograph of 1 centimeter depth. Unit hydrograph of 1 centimeter, unit hydrograph nothing but 1 centimeter depth of rainfall excess. So we need to, I am converting unit hydrograph of 1 centimeter depth of rainfall excess to flood hydrograph of rainfall excess 3.5. So 0 multiplied by 3.5, you will get 0. 51 multiplied by 3.5, 216 multiplied by 3.5. Write yourself. Into 3.5, you will get 178.5. Next, this has 756 and this has 945 and 822.5, 595, 374.5, 217, 112, 35, 0. Just I converted unit hydrograph of 1 centimeter depth rainfall excess to flood hydrograph of 3.5 centimeter rainfall excess. Just multiply these ordinates by 3.5. In the problem, they are also asking us to find out volume, and this is also asked. This is flood hydrograph. One step is finished. Second part of the problem is calculation of volume. Okay, here we will going to make use of Prismoidal formula. Okay, what Prismoidal formula says, volume is equals to, general formula, Prismoidal, I think you when you are in third or fourth semester, you studied Prismoidal formula, trapezoidal formula, Simpson's one-third rule, all those things in surveying. Okay, just take the application of such basic formulas. Volume is equals to, actually Prismoidal formula is equals to H divided by, volume is equals to H by 3, volume is equals to H by 3 multiplied by first ordinate and the last ordinate plus 4 times of even ordinates. Okay, 4 times of even ordinate, y2 plus y4 plus y6 etc. plus 2 times of odd ordinate, y1 plus y3 plus y5 etc. Now it means actually the problem is of 6 hour, so that is the interval. So 6 hour, 1 hour 60 minute 60 second divided by 3 first ordinate and the last ordinate 0 0 plus 4 times of even ordinate, this is y0, y1, y2, y3 like that. So y0, y1, y2, so this is y2 756 plus 945, sorry 822.5. y0, y1, y2, y3, y4, y5, y6, y7, y8, y9 and y10. 4 times of even ordinate, even is 756 plus 822.5, 822.5 plus 374.5, 374.5 plus 756, 822, 374, 112. Okay, next 2 times of that is y1 178.5 plus next one 945 plus 595. Next 217, 35. 217 and 35. After simplifying, you will get volume is equal 86.48 into 10 power 6 meter cube. Yes, 86.48 into 10 power 6 meter cube. Okay, and we need to plot also, right? So very similar to the last one only. So just this is the flood hydrograph and time 0, 178. So first 0, 178, 756, 945, 822.5, 595, 374, 217, 112, 35, 0. Okay, just join all the points. Okay, you need to do according to the scale. Okay, I am writing here just for understanding purpose. You need to do according to the scale.